Hello, good morning, good night, good whatever time of day it is for you. Let's talk about the average rate of change. Start with the definition. The change in f of x over the interval from a to b is the change in f, which is delta f. All right, that's use the right things here. Delta f, Greek letter capital delta, means change in math. It's the second value minus the first value, or f of b minus f of a. And so the average rate of change of f of x over the interval from a to b it's just f of b minus f of a over b minus a. It's just the slope of the lines. So I want you to see this. The average rate of change of f of x over the interval from a to b is just slope. This entire section is find the slope. All right. So no matter how different the words become, average rate of change is just find a slope. Okay. We also call this average rate of change the difference quotient of f over the interval from a to b, and we'll see that in other forms shortly. A line through 2 points of a graph like p and q is called a secant line. Okay, so we have a graph f of x, any 2 points p and q. If we draw a line that connects them, the secant line shows the average rate of change between points p and q. So it's the average tilt, the average change between them. Okay, the units of change in f are the units of f of x. The units of the average rate of change of f are units of f of x per unit of x. So if I have a function of cost of x items, my change in my average rate of change, ROC, would be dollars per item. Cost is the y value, x is the number of items. Cost is in dollars in this example, and I didn't tell you that. So cost per item. Average rate of change, we'll use the units that you found from the beginning. Now we do have this alternate formula. This is really the difference quotient. This is what most mathematicians will refer to when they're talking about the difference quotient. Average rate of change of f over a to a plus h is f of a plus h minus f of a over h. And that denominator of h, we just take a plus h and we subtract a. Right? So the distance is h. We have many ways of representing data. We have many ways of representing functions. So in this average rate of change, we're going to be using table of values, graphs, algebra, and all of them will show us the same thing. So let's look at some examples. Let's look at tables first. Calculate the average rate of change of the given function over the given interval. Include correct units. I'm going to put in some units here. Miles, and this is no. Oh my goodness. We're going to go with hours, and we're not going to do that. My goodness, my brain is just not happening today. I mean, yeah, I guess it's just not happening. No units on this one. We'll look at units on this one, because that's what I was going to write. Find the average rate of change over the interval from 0 to 2. So we know we're using an x value of 0 and an x value of 2. Notice the order 0 to 2, so we'll always subtract right minus left. Always big minus little, right minus left. So 2 minus 0. And then what goes with those? Well, I know f of 2 has an output of 2, and f of 0 has an output of negative 1. So f of 2 is 2 minus f of 0 is negative 1 over 2 minus 0. That's 2 plus 1 is 3 over 2, 3 halves. Yes, you could call it 1.5, but please don't. Get used to fractions. We're going to use fractions a lot. And some decimals are not cool. Some decimals are. All fractions are cool. Kind of. Find the average rate of change over the interval from 0.1 to 0.2. T is the number of hours, and D of T is, the number of miles. Our average rate of change is d at 0.2 minus d at 0.1 divided by 0.2 minus 0.1. Oh, just like a slope, they're lined up on top of each other. At 0.2, my d answer is 6. At 0.1, my d answer is 3. So I subtract my y values, 6 minus 3. I subtract my x values, 0.2 minus 0.1. I'll get 3 divided by 0.1, and 3 divided into tenths is 30. So an average rate of change of 30 miles per hour is what this person did from start to 0.2 hours in. All right, that's what, a fifth, like 12 minutes in, they'd gone 6 miles. All right, so that's using tables. We could do it using algebra. If our function is 2x squared plus 4 and our interval is from -1 to 2, the average rate of change, I have to know what is f of 2, right? The function value at 2. So I put in 2. So I'll have 2 times 2 squared plus 4. 2 squared is 4. 2 times 4 is 8. 8 plus 4 is 12. Remember, order of operations, a step at a time. F evaluated at -1. Everywhere I see an x, I replace it by a -1. Only the x is squared, so only the -1 is squared. -1 squared is 1. 2 times 1 is 2, plus 4 is 6. Now I could substitute these. F of 2 minus f of 1 over 2 minus -1. My f of 2 is 12. F of -1 is 6. 12 minus 6 over 2 minus a negative, or 2 plus 1. That's 6 over 3, which is 2. Average rate of change of 2 from x value of -1 to x value of 2. If f of x is 3x squared plus x over 2, and the x values go from 3 to 4, our interval, we'll evaluate at 4. 4 squared is 16. 16 times 3 is 48. And 4 over 2 is 2. 48 plus 2 is 50. At 3, 3 squared is 9. 9 times 3 is 27. 3 over 2 is 3 over 2. So 27 plus 1.5 is 28.5. 0.5s are really hard to ignore. It's really hard to convince myself to write a fraction when I have a 0.5. But I do other times. Average rate of change is f of 4 minus f of 3 over 4 minus 3. That's 50 minus 28.5 over 1, which is a 21.5. Notice no units here because we do not know what these functions are representing. All right. Calculate the average rate of change of f of x equals 2 over x over the intervals 1 to 1 plus h for all these different h values. So what I'm going to do is I'm going to do the formula in general first. I'm going to find f of a plus h minus f of a all over h, right? So we have the h values, so I'm going to use the difference quotient formula. All right, so instead of an a, it's going to be a 1 plus. So that's f of 1 plus h minus f of 1 all over h. F of, so that's 2 over 1 plus h minus 2 over 1 all over h. But notice we want to subtract fractions. We need a common denominator. Our common denominator will be 1 plus h. So we'll multiply this 2 over 1 times 1 plus h over 1 plus h. So now we'll have a common denominator of 1 plus h in the numerator. This 2 is already there, but I subtract 2 times 1 plus h. What do we have here? We have 2 minus 2 minus 2h. So 2 minus 2 cancels out. I get the minus 2h over a 1 plus h. But that's just in the numerator. Dividing by this h is the same as multiplying by 1 over h. So dividing by h becomes multiplying by 1 over h. I'll have a negative 2h over 1 plus h times 1 over h. That negative, the h with the negative 2 and the h in the denominator will cancel out here. We'll get negative 2 over 1 plus h. Now for my answers that I'm going to enter in the homework, I'm going to take this negative 2 over 1 plus h and I'm going to put in an h value of 1, an h value of 0.1, 0.01, 0.001. So now I'm going to use a table to evaluate in general instead of doing it 1, 2, 3. Instead of doing this 4 different times, I do it once and evaluate instead of doing 4 different problems. Okay, I suppose it would be the same as if you wanted to do h equals 1, you would do f of 2 minus f of 1 all over 2 minus 1. If h is a tenth, you could do f of 1.1 minus f of 1 all over 1.1 minus 1. So you could do this 4 different times. Absolutely, and just use numbers and everything, and you don't have to worry about a little algebraic manipulation. But do you want to do 4 problems, or do you want to do 1 problem and 4 evaluations? That's a personal question. I can't answer that for you. Some of you prefer this method up top. All right. The following table lists the net sales, which is after-tax revenue, at the Finnish cell phone company Nokia during the period 1997 to 2003, where t equals 0 represents 2000. So this is 3 years before 2000. This is 1997. This is 3 years after 2000. This represents 2003. Nokia sales in billions of euros. Compute and interpret the average rate of change of P of t. Okay, over the period from -2 to 3. So I know this will be P of 3 minus P of -2 over 3 minus -2. After all, an average rate of change is just a slope. So I get 29 minus 14 over 5. 29 minus 14 is 15. 15 over 5 is 3. Awesome. The average rate of change is 3. 3 what? 3 billion euro per year. What's in the bottom? The years. What's in the numerator here? This is our billions of euros. So Nokia gained an average of 3 billion euros per year from 1998 to 2003. This is our interpretation. Excellent. Over the period from 0 to 1, I know that's P of 1 minus P of 0 over 1 minus 0. They were the same. 31 minus 31 over 1 minus 0. But that's 0 over 1, that's okay, right? If the 0 is in the numerator, that's okay. 0 divided by 1 is just 0. Nokia did not make any gains or losses from 2000 to 2001. The sales remained constant. All right? 0 billion euros per year was the average rate of change. It didn't change. Right? Average rate of change, blah, 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 blah. It's a slope. Don't overthink it. It's a slope. We're going to make this general soon, but this is just a slope. You've got this. Thanks for listening.